And we're back. So I think it makes a lot of sense when you think about one computer, right? This one computer has bits of ones and zeros, and it can just manage its own data, store its own data. It doesn't need to worry about any communication medium outside of itself. But as soon as more than one computer is involved, right, we ran into this problem of like just sending ones and zeros at that other machine when there's multiple computers involved doesn't give any information about, where is it going, right? What to do with this data, right? So let's talk about the protocol data unit here, right? At layer one, it's just bits, right? Just storage of data, movement of data within one particular device. But now to communicate at the switch layer, layer two, what other information do we really need?
Well, I need to know where it's coming from,
right?
So I can send a response back, and I need to know where it's going.
Right. Yeah, and this is the idea behind the Ethernet frame, right? The protocol data unit for layer two of this OSI model, right? There's a couple other things in there for, checksums, et cetera, but the real big takeaway of this is we need to know where it came from, where it's going, and what are we sending, right? That data portion. And as we move up this layering scale, we're going to see that we're going to fill out that data portion with more and more specific information about how to actually deal with this data. What kind of data are we dealing with, right? And so we talked about switches sort of being the barrier for a local communication, LANs, right? So how is this different than when we think about something like longer distance communication, for example?
Sorry, how do you mean?
Like, what would we do then over a longer distance, right? So we have our switches that are dealing with our layer two communication. You had mentioned before, we have a physical, entry port, like a physical thing on a device that's like a table that is saying, hey, this information came from machine 436F, send it to 436D, right? And that kind of thing, that MAC address resolution is what is happening at layer two, right? But this story becomes more complicated when we get to layer three, right? What are some major differences that we might want to think about when we're talking about longer distance communication?
Well, how much time it takes to get to that other place, maybe?
Right.
Why don't we just use more switches?
Yeah, that's a good question too. Why don't we just use more switches? And I think that one comparison I like to use here is sort of like management at a company, right? At some point, the top layer of the company can no longer be worried about what the bottom of the company is doing, right? And this is very common, right? This sort of distribution of power, and we could think of switches as like our bottom line, right? Are the ones that are doing the very local hands-on routing. Old switches sometimes only had the ability to talk to 4 different machines. That's it, right? And so the ability to scale past that says, hey, why don't we treat this entire sector of the company as if it's this one person, the manager, right? And that manager is who's going to communicate with everyone else. Well, this is the idea behind our layer 3 device, or our router, okay? And our router says, you get one IP address. This router has one IP address, one public-facing IP address that's going to be able to talk to the world. And so any machine on that same network that's talking to that one IP address, okay, is going to be communicating to the world via that router through that IP address. So now we need more information. That data area of that PDU needs to be filled out, right? We had our source MAC address, destination MAC address, but now we need to know about our source IP address, or our Internet Protocol layer 3 address, and our destination IP address. Where should I send this thing? And all of that communication is taken from there and routed and facilitated by your internet provider, right? And so this becomes a much more complicated scenario. Of course, you could also have your own local router 3s, or your own layer 3 devices, or your own routers locally, and you can create your own what's called subnets, right? We hear about nets. That's what a subnet is. It's your own small division of the internet, right? And that's sort of what the internet is. It's a bunch of subnets and a bunch of subnets and a bunch of subnets. All right? And that's a good way to think about it.
Okay.
Yeah. So I think it's time to dive into your layer 3 section of this course, and keep in mind that this is a solution to a scaling problem, right? Like, as we scale up, we need a better set of means. Now we're talking about the internet highway, the thing that is maintained by the internet providers. This is the thing that you actually are paying for externally, right? You can do any kind of LAN party you want locally, right? Have your own, everyone with a MAC address can communicate locally, no fees involved, right? Everything's nice and local. local, but now we need someone to maintain our highways, just like shipping a package over a long distance, right? The next question is going to be, how do we ship that package? How do we want to pay for express shipping? Do we want to, get a receipt of when the person confirms that they received the package, right? How do we want to ship that package? Do we want to put it in a box? Do we want to put it in a bag, right? These are all the next questions. But right now we're talking just about the highway itself, that internet traffic. And so the thing that we're going to need to know is, like delivering a package, where do you live? Right? Where is this coming from? The return address, and where are we going? Right? Everything else was part of the higher level part of this discussion.
Makes sense to me.
Yeah. All right. Well, let's dive right in. Take a look.